So I had a request to offer some advice on this type of Alex topic called solving for a reactant using a chemical equation. If you put the title of that topic into a search engine, you'll probably find lots of people that have made videos explaining how to tackle these types of problems. So the key thing when you're starting with these problems is to identify what are the reactants and the products, and then to get a balanced equation. You need that before you can get going, because we're going to need this thing called the mole ratio. Okay, so this question reads, ammonium phosphate is an important ingredient in many fertilizers. It can be made by reacting phosphoric acid with ammonia. So what that is really telling you is that we have two reactants, ammonia and phosphoric acid, coming together to make ammonium phosphate. So we've got to get this to balance, and looking at this I can see immediately that I need 3 nitrogens there, and that looks pretty good. I can go through and manually balance this, so I have 3 nitrogens on the left, I have 3 on the right. Hydrogens, I've got 3 times 3, that's 9, plus another 3, that's 12 on the left, and then 3 times 4, that's 12 on the right. And then phosphate, or phosphorus, sorry, 1 on the left, 1 on the right. And then finally oxygens, we've got 4 on the left and 4 on the right. So that's one way of kind of doing this, what we call balancing by inspection, just kind of manipulating things and observing if we can get things to balance. There's another way that can really speed things up, and I highly recommend doing, and that's to use an online equation balancer. The one I like is at a website called webqc.org. It's pretty good, and it also does a bunch of other stuff that I'm not going to go through now, but just keep this in mind. If you just go to webqc.org, you can find this equation balancer under their chemistry tools. So we're just going to go NH3 plus H3P, and there it is. All right, and so there we go. There's our balanced equation. It looks just like what we had. Now what WebQC does that's also nice is it calculates the molar mass of everything, which is really helpful for solving these problems. I also recommend, while we're talking about websites, is bookmarking a molecular weight calculator. The one I like is Lentec. You just put your formula in here and it'll calculate your molecular weights for you. So a couple of things going on there that are really helpful. Okay, so we got our equation balanced correctly. Let's move on. This question says, what mass of ammonium phosphate is produced? So how many grams of this guy do we get when we react 3.45 grams of that? So this is a type of problem what we call grams of A to grams of B, and they're pretty easy to do. You take your grams of A, which in our case will be this guy, you multiply that by 1 on its molar mass, you multiply that by the number of B's that are in your equation over the number of A's that are in your equation, what we call the mole ratio, and then finally you multiply that by the molar mass of your B. And when you do all of that, you get your grams of B, and our B in this case is that guy. So we call that grams of A to grams of B, and it really just involves multiplying those 4 numbers together. So you can see we're going to need 2 molar masses and this thing called the mole ratio. So in this case, we've got 3.45 grams of phosphoric acid, and we need the molar mass here, and we know that 1 mole of phosphoric acid weighs 98.0 grams. So that's my first conversion. Then I need my number of B's, so I get 1 mole of ammonium phosphate over my number of A's for every 1 mole of phosphoric acid. So you got that bit done. And then finally, I need my molar mass. And I just can look that up in WebQC, can't I? 149.09. And get 149.09 grams of my product for every 1 mole of ammonium phosphate. And so when I look at all of this, my units cancel out. The only units left are grams. So I know I got it right before I put it into my calculator. So you just got to multiply those 4 numbers together. It's a little bit hard to get everything so it's visible, but we have 3.45 times 1 on 98. I'm not going to do 1 on 1 because that's kind of just 1, isn't it? Times 149.09, and there we go. Now, our original number that was given to us was 3 significant figures, so I'm going to round this to 3 significant figures, so it will be 5.25 grams. All right, we'll do another one, and you'll see that they're done in a very similar way. So this problem is about ammonium perchlorate. We're going to read the description of the problem carefully and make sure we can generate a balanced equation. So it says ammonium perchlorate is the solid rocket fuel that was used by the US Space Shuttle and is used in the space launch system of the Artemis rocket. It reacts with itself. So there we go. We know that that is going to be the reactant to make nitrogen, chlorine, oxygen, and water. And now we have to get everything to balance. I think the thing that I see first of all is that there's going to be 2 nitrogens. So we need, or there is 2 nitrogens, so we need 2 of the ammonium chlorates. That takes care of the nitrogens. The nitrogens are now balanced. It also brings the chlorines into balance. But when we look at the hydrogens, we have 8 on the left and only 2 on the right. So I'm going to need to put a 4 in there. And then they now balance. And then my last thing to deal with is my oxygens. I've got 2 times 4, so we've got 8 on the left. And then on the right, I've got 2 there. And then 4 times 2, that's 4. So that I've only got 6. But hopefully you can see, if I make that 2O2, and then that would be 4 plus 4, which is also 8. So then that would become 8. All right, so that looks like it balances, right? So my balanced equation is 2 ammonium perchlorates react with themselves to give 1 N2, 1 Cl2, 2 O2s, and 4 waters. Now, of course, I can put that into my online equation balancer, NH4ClO4. There it is there. 2, 1, 1, 2, 4. And that's exactly what I got. All right, good. Now, I like to do that as well because I can, get all of my molar masses that I might need. Okay. So now, what it says is what mass of water is made by 3.90 grams of that, and we want grams of water. Okay, so that's my A and that's my B. So we know it's grams of A times 1 on the molar mass of A times by the number of B's over the number of A's times by the molar mass of my B, and that'll give me grams of B. So you've just got to multiply those 4 numbers together. 3.90 grams of ammonium perchlorate times 1 mole of ammonium perchlorate. This is why it's worth putting it into WebQC, 117.49. There we go. And then number of B's over number of A's, so we get 4 moles of water for every 2 mole of ammonium perchlorate. And then finally, times by the molar mass of water, we get 18.02 grams of water in 1 mole of water. Now if I cancel all my units, you'll see fairly quickly that my only unit left is grams of water. So we know we got this correct, and we also know that we're going to round whatever we get 3 significant figures, because that was what our starting mass was. So let's give this a go. We've got 3.9 times 1 on 117.49 times, and the mole ratio is important this time, it's 4 on 2, times 18.02. And there we go. So to 3 significant figures, this would be 1.20 grams of water. Well, that's it. And we got it done. Alright, well, I hope you found that helpful. A couple of examples there. Not really that tricky. You just remember grams of A to grams of B. You do grams of A times 1 on the molar mass of A times the number of B's over the number of A's that are in your equation times by the molar mass of B. And because we're working in an online environment, I think it really helps if you use a online equation balancer, and they'll calculate out your molar masses for you. Now, something you can also do to check your work is if we put that starting mass in, something like WebQC will actually calculate that, the mass of everything else for you. So put 3.9 in there, and it told me that I should get 1.2 grams of water. So that's pretty good, right? We go back to our previous one, we can do the same thing. We have to put the equation in, NH3 plus H3, there it is. And in that problem, we had 3.45 grams of our acid. And there it is. So that leads us to the conclusion that we need 5.25 grams, or we get 5.25 grams of our product. So pretty helpful, those tools.